Hey everyone, just checking the audio is fine. Can you just send the text in the chat to let me know it's okay, that you can hear me? Awesome. Okay, great. Hi, I'm glad you joined. So yes, I was supposed to have a collab next week, but I figured since your assignment's approaching, I'll move it forward. So I'll move it earlier, should I say. And yeah, I'm having one today. So I'm going to cover dispersion measures, but before I do that, there's some questions that I got from students. So just remember that these collabs are actually more to address questions that you have. That's priority. That's what they're here for. So if you email me questions, I'll if I can't get back to you on email, and I feel it might be better to just do a collab on it, then I'm going to address that first, and then I'll cover any material that I think necessary. But so use these collabs to actually address the problems that you're having with the material. Okay, so let me just share my screen. Okay, so I'm gonna share this kind of whiteboard. Yeah, this whiteboard. I'm hoping you can see it. There's a table on the top left, and on the right there's a blue shaded table. Just give me a heads up that you can see it. Can see, perfect. Okay, so I'm gonna go back to it. All right, so one of the questions I got was looking at this table in the top left, right? Say you're given this data. This is a cross tabulation table. Can see, okay, great. All right, call Google Class, thank you. All right, so to send me a message if you can't see it, or if there's anything you want me to stop and explain again, just send a text message. All right, so let me continue. So this is your data on the left. So on the top left column, so what is it telling you? Okay, so let's look at that number 7 in the top. So what it's telling you is that there's 7 female shoppers that go to Checkers. All right, then the number 3 next to it says there's 3 male customers that go to Checkers. Let's look at the number 10 below that. So that says there's 10 female shoppers that go to Pick and Pay. I think you kind of get the gist of it. It's a cross tabulation table. When I say cross tabulation, it means it cross tabulates 2 variables against each other. And in our case, it's supermarkets on the left versus gender on the right. And in the end of the right, on the last right column, if you look at the first row, just following Checkers, it says there's 7 female customers and there's 3 male customers. If you add that up, you get 10. And that's where you get that last value on the right. That's your row total. Now suppose you're asked to provide the row percentages of this table. And what you need to remember is if they say row percentages, that means if you go along the row, it must add up to 100%. All right, so what that means is, let's just look at Checkers, right? Let's just isolate our attention onto Checkers, and we see that there's 7 female and there's 3 males. So all you need to try and figure out is, looking at just that row, what percentage of people that go to Checkers are female? So that will be 7 divided by the row total, which is 10. So 7 out of 10, that's 70%. So you would have 70% here. All right, and since there's only one other category, which is male, and since you've got 70% here for female, then the male has to be 30%. But if you want to calculate it again, that's perfectly fine. All you do is you look at the males. There's 3 males, and the row total is 10. So 3 out of 10 is males, so that's 30%. All right. Okay, I'll do one more row. Let's look at Pick and Pay. So looking at that first column, what do you think this value is here? Just like how I did the first row, give it a shot. What is that value? All right, I'm going to come back to the chat again. 59%. And Marianne, 58.8, yeah, I think you guys are rounding it. So you did it by 10 out of 17. Yes, that's how you got it. 10 divided by 17. And I'll just do it here. Yeah, that's how you got it. Right, good, everyone. So everyone gets it. So that's basically how you do your row percentages. All right, so you would have that value. What is it? 58.8 or 59, rounding it up. All right, so that'll be 59%. And you can work out the next one, but since there's only two categories, like I said, this will just be the remainder of 100%. So it's 100 minus 59, which is 41%. Right, you can do this when there's just two categories. Obviously, when there's three categories, then you need to have all three of them adding up to 100. All right, so all you do is you take your whatever row percentage you want. So say you wanted the first row and first column, you take that value and you divide it by the row total. You divide it by this and you get the row percentages. All right. Okay, I hope that makes sense. So far so good. Good. All right. Okay, then the other question, I'll continue, is a Pareto distribution. Okay, so as far as I know, a Pareto distribution you won't be tested on it, but since you've asked about it, I will explain it, right? Okay, and the example in the textbook, so what it is basically you if you would have done ogives by now, right? That you would have done, and it basically is it's kind of a modification of an ogive. All right. So let's just say this is the data you're given, right? You're given customer complaints, and there's only 8 categories of complaints. So a customer can complain for poor product knowledge, or product options are limited, the internet site is frequently down, and you kind of get the picture all the way to the payment options are limited. So these are the 8 categories they can complain about. And what you have in the last column is a count, basically how many customers complained for that complaint, right? File that complaint. So the 26 says there's 26 customers that filed a complaint for having poor product knowledge, all right? And 47 of them complained for product options limited. All right, so what you need to do for Pareto distribution is you need to put the frequency, or in other words, the count, in descending order. Now, if you do that, let me just copy and paste it so you can see it. All right, go back here. All right, so what you do is take that same data, all right, and what I've done is here is, let me see if I can make this a bit bigger. Okay. All right, so let's look at the table on the top, right, the raw data. You can see that the largest number there is 82. So it means cost of service cost of service is excessive is the number one complaint, or should I say the most frequent complaint. That's 82. So I'll put that first. So that's what I have in the bottom table. All right, I put that first, cost of service 82. That's what I have. And there's a code given to it. Now the code is just basically when you're doing the chart, it's going to make it easier to interpret. That's all the code is for. Instead of putting these labeled cost of service on a chart, which is long and takes up a lot of space, you put this code here. All right, so that's all it is. So all you do is you just rearrange everything and you bring the highest one to the top based on the count, and you've got that. So the second one, what's the second highest complaint? And if you look at it, then the second largest number next to 82 is 66, and that's slow response times. So that you put next, all right? And that is code number 4, slow response times, and the count is 66. And I do this going all the way down until I get the smallest number of complaints. The smallest number of complaints is internet site frequently down, and that's 12. 12 is the smallest number, so that'll be in the bottom of the table. So you would have these first 3 columns of this bottom table, right? Looking at this bottom table, you would have only, all you have to do is rearrange this based on the first 3 columns. So far so good? and I put it in descending order. Just give me a heads up if you're okay. You want me to go back and explain this? Awesome. All right, so let's go back there. All right, so I've got these first three columns. Okay, so the next thing you need to do, and you would have done this as already as well when you're dealing with group data, and we did group data in the last collab. All right, so what I'm doing is I'm gonna create a next column, this column here, which is the cumulative frequency. And what I do there is I look at the frequency, or other words, count and frequency are the same thing, right? I just, since there's nothing before the 82, I'll just write the 82. All right, but as I go down, I start adding up the numbers. All right, so as I go down, it'll be 66 plus 82, which gives me 148. When I go to the next row, then I add up all three, which is 47, 66, and 82, and I get 195. Right, then I go to the fourth row, I add 30, 47, 66, 82, basically everything from that 30 below it and before it, and I get 225. And I do this going all the way down until I have 300. And the way to sense check your answers is look at your last number, which is 300 here, and that must always add up to all of these numbers here. If it doesn't, then you probably made a mistake somewhere. So that's a way to sense check your cumulative frequency. All right. Then the last column I'm going to create is the percentage of that cumulative frequency. And it's nothing fancy. All it is, right, look at the total. The total is 300. That's how many complaints you have altogether. All I do is I take each number of the cumulative frequency and I divide by 300. I'm just converting it to a percent. 82 divided by 300 gives me 27%. 148 divided by 300 gives me 49%. Right? And as I go down, you'd expect the percentage to increase because the cumulative frequency column is increasing. Right? So you're getting closer and closer to the 300, so you're getting closer and closer to the 100%. So the last row will be 300%. All right, so everyone with me and how you get those last two columns that I've got? All right, I'm going to come back here. Awesome. All right, then the last part is very, very simple. All right, it's just charting. It's charting this data. Right, you're going to chart this column and you're going to chart this column here. Let me mark it in red. So so I'm going to chart this column and this column here. So if I let me copy the chart. Give me a second. There you go. There's the chart. All right. So this column, like my colors. So give me a second. All right, I'll make this color blue. This blue column here, the last column, is the line that you see in this chart. All right. So the line goes from 27%, 49, 65. That's how I'm going. 27, 49, 65. It increases, going all the way to 100%. That's the line. And this uses a secondary y-axis. It's the y-axis on the right. Okay, so it doesn't follow the scale on the left. The scale on the left is for the bars, which is this red column here, right? That's the bars here. So all it is, I go 82, 66. So you're basically plotting a bar chart, right? You would have been familiar with the bar chart from the previous learning units and charting. So you could do one at a time, right? Do this column first, do a bar chart for this, and the labels on the axis. See, you could have put description, but as you can see, if you put this description, it's going to be too big. It's going to be quite big to write here. So in this question, they made it easy for you. They gave you a code. So instead of putting the description, put the code instead. Right? So 7, the next code is 4. That's how you got the 4, and you go all the way to the last code on this table, which is 3. Right? Then the bar, the value of the bar is the count, so the frequency. So the first bar is 82, second bar is 66, third bar 47, right? And because you put them in descending order, you can expect the bars to start dropping off like this. All right, and then once you finish the bars, then you just do the last column as a line, here, this last column, do it as a line here. And remember, the scale for the line follows the secondary axis. It follows this axis here. And that's your Pareto distribution. So why is the Pareto distribution so useful? Okay, well, at a glance, because look at this problem, right? This problem gives you customer complaints. And if you just look at this graph, right? If you look at this second point in the line, it tells you what percentage belongs to certain categories. So look at this 49. 49 is almost half, right? 49 is almost 50%. So almost half the complaints are made up of just two complaints, which is 7 and 4. That means almost half the complaints come from, sorry, not this table, I didn't put it, this table here. Half the complaints come from just these first two complaints, which is cost of service and slow response times. All right, that's how you interpret it. Does that make sense? Awesome. Okay, is there anything you want me to go back on? I think we're all good, yeah? Then I'm going to go back to, oh, the other question was about numerical and categorical variables, right? I got that question as well. Okay, so what you need to know is for a numeric variable, you can take on a number, right? And that number has an order to it. So if I ask you for your age, right? Say I had like 10 students and I asked them for their age. Student 1 said 27, student 2 said 29, student 3 said 25. You get where I'm going with this, right? These numbers, right? They're numeric, okay? So because they're numeric, um, well, they're a numerical variable, I would say, right? They fall under the category of a ratio variable. So it's numeric, or in other words, qualitative. They fall under the category of qualitative. So I'm talking nonsense. Please ignore that. Quantitative, sorry. It falls under the category of quantitative, right? All right. Quantitative are numerical variables, like this example here, it's age, all right? It's ratio and it's discrete. And what do I mean by discrete? Discrete means it's whole numbers. So there's no 25.5 or 29.8, right? No one gives their age as that, right? Although it could be measured as that, but the thing is no one gives their age as that. So it's discrete values, right? It's whole numbers. The other quantitative variable you can have under ratio is continuous variables. Continuous. Can't put it here, but just remember it, continuous. And continuous can take on decimals. So for instance, if you're measuring temperature, for example, that can be 27.5, 29.8, etc. Even money, if you think about money, it can take on a cent, so it takes on a decimal value. That's continuous, right? So those are numerical variables. Both these examples that I gave you, these are numerical variables. Then you get categorical variables. The categorical variables are, look at this example I did first. Someone can either be male or female, right? So that's categories. It doesn't take on numerical values, all right? So these are an example of qualitative, also known as categorical variables, all right? It takes on categories. So these are two categories that you can take on. Even the row variable that you see here, it's supermarkets. These are examples of categories, right? Checkers, Pick and Pay, Spar. The category, so it's a qualitative variable, and it's made up of 3 categories. All right, so that's the difference between quantitative and qualitative variables. Qualitative is also known as categorical. All right. So yeah, that was the questions I had for numeric and categorical variables. Does that answer your question? Is there anything you want me to explain on that? Shall I just continue? Assume everyone's good on this. Okay. We'll continue. All right. So I'm going to move on to dispersion measures, right? So I'm going to delete this. And, sorry, I'll actually just open up that one. This is what I want to cover today, and dispersion measures. Now, last week I covered central measures. I showed you what a distribution is. Oops, sorry. Let me draw this here. Right, so we had your numeric axis, and then I showed you there's different shapes of a distribution. You get a symmetrical, you get a skewed distribution. This one is almost symmetrical, and central measures covers where the data is centered. That's what central measures is, and that's what we did last week. Today I'm going to cover dispersion measures, and as the word says, it tells you how much your data is dispersed. So it's actually this direction. See how spread out your data is, how wide this curve is. And there's different ways of measuring that, and you need to understand that. All right, so we're going to cover measures to kind of show how spread out the data is. So the first example is, we'll look at this example on the top left here. And what I have here is credit card expenditure. So there's 1, 2, 3, 4, 5, 6, 7. There's a sample of 7 people. We looked at how much they spend on their credit card, and the first person spends 3,200. Second person spends 3,750. The last person spends 5,200. Now I have ordered this data for you. So I went from the smallest to the largest, and I put in order for you. Just remember, you're not guaranteed to be given data that's ordered. You may have to do it yourself. All right? Okay. So now that we've put in order, all right, so what we're going to do is we're going to start working out measures of dispersion. And if you look at your formula sheet, it has all these equations given to you in your formula sheet. All right, so you don't have to memorize the formula. You just need to understand what each of them are and how to use them. So if you ask for the range of your data, right, that's this first formula here. Right, this is one of the easiest measures of dispersion to calculate. All it is you take your maximum value and you take your minimum value and you subtract them, following the same formula, and that gives you your range. So in our case, the range is 5,200 minus 3,200, which is 2,000. So your range is 2,000. Easy one. Does it make sense? I'm hoping people can fall asleep here. Okay. All right. So we're getting there. All right. So the range is easy. All right. Let's go to something a bit more complicated now. So now we have this S squared. Now S squared, you must learn the terminology for this, okay? So S squared is your variance, because in the question, they may tell you calculate the variance. They won't tell you calculate S squared. You need to understand that that is S squared. And if you take just S on its own, that means if you take the square root of S squared, you get the standard deviation, all right? So this here, this part here, that's your standard deviation, all right? So we're going to calculate the variance. All right, so what I'm going to do is I'm going to basically write this data in a different way. All right, so I'll show you here. Give me a second. I'm going to back here. All right, so what we do is look at this first column. The first column here. All it is, it's the same data that I have, all right? And I just wrote them going down one column. It's the same thing, 3,200, 3,750, 4,200. You can see where I'm going. The last value will be 5,200, and there it is here, the last value. All right. Okay. So now, all I've done is I've rewritten my data in a table, and I listed it going down the column, the different rows. All right. So I need to follow the formula here, all right, to calculate this S squared. Now, if you look at the first term on the numerator, it has something like this: sum x squared. All right. So I'm going to calculate this value here. All right. Now, what is the x? X is just basically the data. Right. This is your x1. This is your x2, all the way to x7. This is your last data point. So what this is telling you is square each of the x values and then sum it up. So do this first, square each of them, and then add them up. And that's what I'm going to do here, this column here. So I'm going to square each of them. That means, see the 3200, that's my first x value. I square it, that means raise it to the power 2, or in other words, 3200 times itself. Right, if I do that, if I square it, I'll get this here. It's 10,240,000. All right, where is that? Sounds about right. Yeah. Can you just double check that? 3,200 squared. Oops. Pretty sure that's the right value. Yeah. Everyone following me? Did I lose anyone? You can do it in your calculator if you want. 3,200 squared gives you 10,240,000. I do the same thing for the next x value, which is 3,750. I square it, and I get 14,062,500. So I'm going to make sure everyone's following here. Okay. Okay, awesome. All right, so let's get back. All right, so I do this for all the values. I square all my x values. Right, so that's what I've done here. I've squared it all up. And now look at this symbol here, the sigma. This is summation. That means you add them all up. So all I do is I add all of these values up. Okay, and I'll get this first term on the numerator. I'll get this entire thing here. All right, add them all up, and I'll get that value. All right, and if I add them all up, I'll tell you what the value is. It's 40. Sorry. It's 132,522. Give me a second. So it's 132,552. Second, 552, 522, 500. This is 522, 500. Okay, so that's the total, right? I add them up and I get this total here. So I have this term here in the equation. I've got this value here. All right. The next part is this minus x bar squared. So remember, the whole formula is this: s squared equals sum x squared minus n x bar all squared all over n minus 1. All right. Now, from last week, let's see if you remember. What is n when you're given data? If you recall what n is the number of data points. In this example, we have 7 data points. If you count how many people we have in our data set that have expenditure of credit cards, it's 7. So your n is 7. So already we got our n equals 7. The x bar, you guys should know how to do this now. From last week, we did this. It's just basically your average. X bar is your average. So find the average of the data and square it. All right. So whatever the average is, you find it and then you square it and you'll get this whole term here. All right. So now on the numerator, let's just look at this part here. I know I'm writing a lot here, but just hang with me. The numerator, we got the sum x squared, which we did already, which is this, right? Then we're going to subtract n, which is 7. We got that value, we know our n, and we multiply it by the mean, which is x bar, but it's all squared. The average is squared. So that's your numerator. And then you simply just divide it by n minus 1, which is 7 minus 1, and that gives you your s squared. That'll give you your s squared value. Does that make sense? So I basically showed you how to find all the values in this equation. All you do is plug it in and you'll get your variance, s squared. Okay, all right, fantastic. All right, so that's your variance. Oh, sorry, where am I? So that's your s squared, right? So I showed you how to get the s squared. Whatever your s squared is, right? And say hypothetically it's 1,000, right? But in this case, it's not going to be 1,000. I doubt it. But let's just say it is 1,000. If you wanted your standard deviation, that means you just take the square root of your variance. So you take the square root of 1,000, right? And that would be your standard deviation. All right. So when you have to work out the standard deviation, you generally have to work out the variance first, and then all you do is you take the square root of the variance, and you get your standard deviation. All right. So that's S squared and S. All right. Now I'm going to go on to the quartiles. All right. Let me get my eraser out here. Mhm. I'm hoping this is making sense. We're getting there. All right. Let's go into the quartiles. All right. I'm going back to quartiles. All right. So say you ask for this data on the left, the top left data, ungrouped data. Say you ask to find the first quartile. Right? If you ask to find the first quartile, you need to find Q1. That's what it means, right? That's what the notation is for the first quartile. All right. So the first step to do it is to find the position. Find the position of the first quartile. Now, the position is given by the formula. For the first quartile, you can think of it as this, right? What is first quarter? First quarter is 1 over 4, right? So it's 1 over 4, right, times your n, and I put it in brackets, n plus 1. Or in other words, I can write it like this, n plus 1 all over 4. But the reason why I wrote it like this on the left is that you can see the quarter. That's what the Q1 is. Your third, if you ask to find the third quartile is basically 3 quarters. So Q3, the position of Q3 is n plus 1 all over 4, but the numerator, remember I told you it's 3 quarters. So it's 3 times that. That's how you find the position. So let's just work with Q1 for now. All right. I'm going to work with Q1. I'm going to just take this because I want some space to write. All right. Let's find this position. All right. Let's go and find this position. All right. So we know our n, right? Our n is 7. Right. So our n is 7. So if I wanted the position for Q1, I'm following this formula here. Right. So it's 7 plus 1 all over 4. And what is that? That's 8 over 4, which is 2. With me? So what that means is it's the second number. That's what the 2 is. It means it's the second number. If you put your order in, put your data in order, it must be put in order. Go and look for the second number starting from the smallest one, and that's here. So that's your first quartile. Your Q1 is 3750. All right. Right, now let's work out Q3, our third quartile. Right. Now, third quartile, remember what I told you about the position. The position is 3 times n plus 1 all over 4. What is that? If you work that number, what do you get? You know what n is, it's 7. That number is 3 times 7 plus 1, which is 8, which is 24 over 4, which is 6. That's the 6th position. Nice, nice, well done. So that means it's this. Remember, this is not the third quartile. It's only the position of the third quartile. So when I say position, that means you need to go and look at the numbers and see what's in position 6. And what number is in position 6? It's 4,800. So your Q3 is 4,800. Sorry, 4,800. All right. So you got your Q3 and your Q1. Now what is Q1 even mean? Why are we even bothering to calculate this number? Well, your Q1, right, as I said, it has to deal with 1 quarter, or in other words, 25%, right? A quarter is 25%. So your Q1 tells you that 25% of your data lies below this number. In other words, 25% of credit card expenditure is less than 3,750, right? Now your Q3, it's 3 quarters. So what that tells you, now 3 quarters is 75%. So it means 75% of the sample spend 4,800 and less, right? 75% of the population spend 4,800 and less. Or you could also say 25, because remember 75 spend less than that, so the top out must be 25, right? Because 75 plus 25 is 100%. So in other words, you can also say 25% of them spend 4,800 and above. Make sense? I'm hoping people didn't fall asleep. Everyone's following. Good. Okay, great. Okay, awesome. All right, so now you know how to find the quartiles. Now I'm gonna change the data, but just to kind of make it a bit more tricky, because this is the kind of problem you would get in the test or an exam, right? So I showed you how to find Q3 and Q1. Just before I go on, there's this other formula here. It says interquartile range. To work out your interquartile range, you need to know what your Q3 is, and you need to know what your Q1 is. And in our case, we did both of it. We've already calculated it. So if you want to know your interquartile range, all you need to do is take your Q3 value and you subtract your Q1 value. So that's your 4,800 minus your 3,750, and that will give you your interquartile range. What that range tells you is that, remember, for your Q1, you got 25% is below it, right? And then for your Q3, right, you got 75% is below it. Now, if you're subtracting your Q3 and your Q1, right, if you're subtracting it, that means you're keeping, remember, you're taking away this 25% because you're subtracting it, you're removing this 25% from the 75%, so you're left with 50%. So what you're saying is 50% of your data, 50% of your data here to here is the range of where 50% of your data lies. Okay, so it's saying 50% of your data spans a range of 3,750, because that's your Q1, to 4,800. That's basically what your interquartile range means, right? That's how you interpret it. But calculation is very easy, right? It's given to you. You don't need to memorize it. You just need to work out the Q3, work out Q1, and subtract it. All right. If you had to work at quartile deviation, the formula is given for you as well. It's the same interquartile range, but you just divide it by 2. All right. Okay. So yeah, you don't need to memorize the formulas. You just need to understand how to get the values that's needed to calculate it. All right. So now, gonna change things up a bit. I'm gonna work a bit quick here, but still, if you are not following or you're confused, please stop me. I will go back to explain something. Right, so I'm going to remove this. All right, I'm going to remove one of the data points. All right, and actually, you know what? Let me add a data point. Let me add another data point there. So I'm going to take this out. All right, so let's say I add another data point. We'll make it, instead of 5,000, let's make it, oops, sorry. Okay, I'm going to make it, say you had another data point that was 5,500, right? So along came this 8th customer that spent 5,500. So now your N is 8, okay, 8 customers. And now let's say you're asked to work out what Q1 is. Now you got to work out what the first quartile is. So the position is still the same. We've got to work that out. It's N plus 1 over 4. Okay, now n is 8, so 8 plus 1 is 9. 9 over 4 is, I'm doing my calculator, so shame on me, but 2.25. If you work that out, you'll get a value of 2.25. 2.25. Right, so that's the position of your Q1. Everyone with me? This is straightforward. Just put the 8 into the n and put your calculator, you'll get this. So now it's not a pretty number like 2 like before, and this is why I added this extra data point, okay, because kind of show you what to do when you don't get a whole number. So now we've got a 2.25, so it means you can't just take the second number. It's not as straightforward as that. What this 2.25 means, you got to take the second number, but if you want to be precise, you got to go, look, this is where the decimal comes in, right? This is where this decimal comes, 0.25. That means you got to go 0.25 inwards between the space of 3,750 and 4,200. All right. And what I mean by that is, all you do is, okay, look at the second number, right? That's what this number in front of the decimal is. That's the 2. So it means look at the second number, which is 3750. All right. And you need to take this difference here, this decimal difference, 0.25. You need to take this into account. And how much of it is basically what is the distance between the second number and the next number. And how you get the distance, you subtract them, right? 4,200 minus 3750. Right? So this was the second number. This was the second number. And we got the second number because what's in front of the decimal. And we take the next number, the number after the second number, which is the third. Right? And then the 0.25 comes from the decimal that you got from the position. That's where you get that. And if you work this out, that will give you the first quartile. That is your Q1. Everyone? Okay. Thanks, Hannah. Yeah, that sounds, yeah, that looks about right. Yes. Just remember, class, when you're doing this, brackets are very important. I've seen a lot of students make mistakes just because they forgot to bracket. Okay. So enter it exactly like as you see I've written it. Obviously, I didn't write it as neat, but forgive my free handwriting. But you would enter it like this in your calculator: 3750 plus 0.25, and then brackets 4,200 minus 3750, close brackets, and you get the number, which I believe you have, which is 3862.5. And that makes sense because the number can't be more than the third number because it's somewhere in between these two. It's somewhere in between 3750 and 4,200. And the number that you gave, yeah, that number makes sense, 3862. And I'm gonna leave it for you to work as the exercise. But the most important thing is the method, that you understand how to do it. Okay, so is that a yes, you understand, you're good? Okay. Or not? I'll explain that again. Are we good? Okay. All right, class. Okay, so I'm gonna go back. Thanks, class. I need the feedback. I do need that, so thank you. All right, so I've done. Okay, so I've done the important stuff that I needed to do for ungrouped data. Okay, cool. Thank you. Thanks. And then I'm gonna erase this. Okay, so I've done ungrouped data. Okay, I've showed you how to work with measures of dispersion for ungrouped data. Now I'm going to go into grouped data. Okay, and I'll copy some data across. I will copy some data across. Give me a second. All right. Now this data is data we did. Sorry, not here. Yeah, data we did last week for the central measures. All right. Okay. So what do we have in our first column? All right. In our first column, we have grocery spending. Now, it's people that spend between 0 and 400 Rand. There's no one that spends that. That's why the frequency is 0. Now if you look at the next row, it's 400 to 800. How many people spend anything from 400 up to 800, not inclusive of 800? That's why that round bracket is there. We have 7 people spending between 400 and 800. Then we have 14 people spending between 800 and 1200, and you kind of get where I'm going with this, right? Then there's this one person that spends an extraordinary amount between 2000 and 2400, all right? So you kind of get the idea. This is the data that's given to you, and the first 2 columns represent your the class ranges of grocery spending, and the second column is how many people spend that amount, right? So this data should look familiar to you for those that were at those that attended the collab last week or even watched the recording, and I'm hoping you did. All right, so now if you need to work out the say the variance now, right? So now you need to work with the variance, but it's for group data. That's when you need to use this formula here that I'm encircling in black, right? And you can see this formula has an f in the formula. So it has a sum fx squared. Now, if any of you recall from the last collab, when you have group data, the x represents the midpoint. So the midpoint of the class interval. So what is the midpoint for the first class interval, the 0 to 400? It's the halfway mark between the 0 to 400, which is 200. So that's our first x value. And remember, we did this and you entered the values into your calculator. All right, it's the same thing. So now for the next row, the midpoint is 600. It's the halfway mark between 800 and 400. And going all the way down to the last row, the midpoint is 2200. So that's our x values. All right, so we got our x that we need for this equation. The next thing we want to do is, okay, so now if you look at this first term, so with group data class, would it be correct if we do it this way instead of just no, then putting the 0 and not the 400? Yes, good point. Okay, so if you had to do it, let me go back to the chart, right? So you see, the notation that I have is this square bracket 0 to 400, and I have a round bracket here. Now the round bracket means you don't include 400. So when I go to the next row, I am going to include the 400. Okay, and then the next value is 800. So I don't include the upper limits, but it's included when I go to the next row as a lower limit. Right, now this is the notation I've used here, but the notation you're talking about, okay, so if you had to use your notation, the first row, it would be 0, all right? You put your x there if you want, so it would be less than equal to, because I'm including the 0, right? So that's why I have the less than equals to x, but the next part is less than 400. It's not less than or equal to. And then the next row, you can see where I'm going with this. It'll be 400 less than equal to x, and strictly less than 800. That's how you would write it. Does it answer your question? Awesome. All right, okay, so let's continue. All right, now, and right now, let me see if I can, sorry, where are we in the textbook now? Oh, I'm not sure, I don't have the textbook here, but you're on dispersion measures of dispersion. So you can someone can say what chapter it is. But you're on learning unit 2, I believe, yeah, learning unit 2. I can double check the learning unit 2. Sorry, class, give me a second. Yeah, you're learning it too, right? And someone can just say what chapter is chapter 3. Thanks, Marianne. Okay, so let's continue here. All right, so now we found the first column is given to us, the second column is given to us, the third column we have to work out as the midpoint. Right, now I'm going to start working out this equation here. So the equation, if you look, it's s squared equals sum f x squared minus n x bar. I'm going to rub out this top part now. I don't need it. Okay, minus n x bar whole squared, right? All over n minus 1. So the first thing I'm working out now is this part here in this equation. All right. Now, if you look at it, remember what I told you, when you got a summation, you do everything in front of the summation first, which means first find your x squared and then multiply it by f. So we have our x, it's the midpoints. So if I want x squared, I just square each value. So the 200 squared is 40,000. All the way down to 2,200, if I square it, I get 4,840,000, the last value. All right? So I've got my x squared, and now I need to multiply by f. So all I do is I take the frequency column f times x squared, which is 0 because the f is 0. The next one is 7 times 360,000, which gives me 2,520,000. And you kind of get where I'm going with this, right? Take all the f values and multiply by your x squared values. 2,200 times is 4,840,000. To that, yeah. Something not right here. Wait, hold. Sorry, the frequency is 1. Sorry, frequency is 1. 1 times x squared, which is 4,840,000, which gives you the same thing. Okay, class, following? That's how I get this last column here. I'm simply just taking f times your x squared column, and I get all these values. So before I go on, make sure you understand that. All right, cool. All right, so now we've got our fx squared, so we've got this, and remember, now you do the summation. So all you do is you sum this column up. You sum this column up, you will get this value here, this 40,880,000. So we've got this value here that I encircled, which is 40,880K. All right, now message. So do we have to show how we got the x? Yes, before we're doing the fx squared. Yeah, so I'm doing it the long way. I'm going to show you both the short and the long way, okay? And it depends on the mark scheme. If this question is 2 marks, do it the short way. But if it's more than 2 marks, do it the long way, which I'm doing it right now. Follow this method, all right? All right, so let's go back. All right, so we got our fx squared. Right, the next thing is the second term here, this n times x bar squared. Now last week I showed you how to find the average for group data, right? I showed you how to basically you can put all the x values into your calculator. So your calculator will have an x column, it'll have a frequency column, right? Right? You put in all the midpoints, you put in all the frequency values, and then you pull out the x bar value using your stat function. All right, so if you're not familiar with that, please go over that video again. All right, oh, remember you can use the formula, this formula here, sum fx, right, all over n, or the sum of n, sum of f, right? So that's how you find the x bar. All right, you find your x bar using your calculator. You put in all these midpoints, put in the frequency, and then you will use the stat. You'll use the shift button. You'll press 1 in your calculator for the Casio guys, right? And you'll look for this value here, x bar. All right, so we know how to find the x bar. If you got that, all you do is you square the value. So whatever value you get, you square it and you multiply it by n. And from last week, how to find n is you sum up the frequencies, right? Your sum of your frequencies is your n. So you got every value you need to put into this equation to get your variance. The assignment states that we must use 5. It doesn't show what is the inclusive number or not. Yes, that's fine, Grant. Yeah, you can assume that you don't include the upper bound. It is common practice that you don't include the upper bound in each class. Okay, class. So everyone understands how to find the values for this equation, right? I've showed you how to find the sum, this value here, sum fx squared. This is kind of new to you, but the x bar, that was done last week. Please revise that. I showed you how to find that. All you do, you just raise it to the power 2. You multiply it by n. Our n is the sum of your frequencies, which is 30, right? And then you divide it by n again, but you subtract 1, n minus 1 in the denominator. That'll give you your variance. And once again, if you wanted your standard deviation, you just take the square root of whatever answer you found for s squared. All right? Thus, I'm going to take that as good to go. Need to do, yes, Marianne, you definitely have to do more examples. But this is to show you how to do it. Okay, for this entire course, you need to work through problems. That's what actually sticks to memory, and that's how you get the hang of it. All right, the last one I want to do today, before I close off, is I'm going to show you how to find the quartiles for group data. All right, so I'm going to erase this and watch this video again. If you missed, it seems like you're following pretty much everything, but it's good to watch this again to consolidate your understanding and work through problems. All right. Now, last week I showed you how to find central measures for group data, and it involved using an equation. In the same way, you can find your quartiles using this equation, which is given to you. So say I wanted the Q1. Right? The first thing I need to do is determine what the position is of Q1. Now, in this course, when we're doing the position for ungrouped data, for the first quartile, it's n plus 1 over 4. But, we're not, it hasn't been consistent in that for group data, we don't add the 1. So just remember this. I know it might be annoying, but you just have to remember this, okay? So for ungrouped data, it'll be plus 1, but for group data, it's just n. There's no plus 1. Okay, so now in our example, your n is 30. So it's 30 over 4, and what does that give you? Work it out. 7.5. Right? Let's see if you got that. Yes. Thanks, Marianne. Now, let's go back in. Now, this is the position. It's not the first quartile. Please repeat about the grouped and ungrouped. Sure, Kiasha. All right. So for position, right, when you want to find out position of your first quartile, right? Okay. For ungrouped data, like the example I did earlier today with the credit card expenditure, the position for Q1 is n plus 1 over 4. Now this is for ungrouped. I'm just going to put U grouped. However, for group data, like the example we're doing here, because we're not given the values explicitly, we're just told what the frequencies are of people spending that amount. For group data, the position is given by n over 4. So the difference is, you can see for ungrouped, it's just a plus 1 in the numerator, whereas for grouped, it's just n. And this is for grouped. You're welcome. All right. So in the same way, if I had to find the position for Q3, all right, it's not 3 into n plus 1 for grouped. It's just 3 into n over 4. Okay. All right. So I need to erase this. So I've got the position. All right. So this part should be very simple if those that followed the last collab, right? So I'm going to use this formula here for Q1. It's given to me for group data. And you can see there's a first term here that has OQ1. Now we worked out the position to be 7.5. Now you would round this number up, make it 8. Okay, round it up to 8. And the reason being is because frequencies aren't given as decimals. Frequencies are given as whole numbers. So I move it up to 8, I round it up to 8. Right? Always round it up, okay? Even if it's 7.2, even if it's 0.2, make it 8, all right? So what I'm trying to find is, where is the position of the 8 number? If I put the numbers in order, which bracket or which class would the 8 number fall in? Remember we did this last week when we were finding the median interval. If we were finding the middle number, you try and see where the 15th number is because you got 30 numbers. But now I'm looking for the 8th number. And the 8th number would be in which interval? Let's see, Grant, good, let's say, good try. If you look at the frequency, you've got 7 numbers when you get to the second column. So we still haven't hit the 8 mark. But if you get to the third row, you've got 14 numbers. So you've got 21 numbers already when you get to the third row. So the 8th number has to be there. So that's your interval, the 800 to 1200. Yes, yes, I think everyone's getting that. Okay, great. Does everyone understand that, right? And it's very important you get the interval right. If you don't get the interval right, then everything else goes wrong. Okay, once you get the interval, then everything from this formula is easy. Remember from last week, this value here, that you have a value plus everything else, that first value, the OQ1, means it's the lower limit of that interval. So the OQ1 is 800 because that's the lower limit. Remember that the interval goes from 800 to 1200, so the lower limit is 8200. The class interval, I'm sorry, the class width, same as last week. How wide is this interval? It goes from 800 to 1200, so it's 400 in length. Just take the upper limit, subtract the lower limit. Your n, we've got that already, it's 30, all right? And this f less than, if any one of you remember from last week, the f less than is all the frequencies before the interval added up, which is the 7 plus 0. The 7 plus the 0, which is 7. And the last value on the bottom of this formula, this FQ1, what do you think that is? Take a guess. You got to try. F is frequency, Q1 is, it's the first quartile interval, it's the Q1 interval. So what do you think FQ1 is? It's the frequency of the Q1 interval, which is, looking at the table, excellent, it's 14. The Q1 interval is this, as everyone said, all of you said it, this is the interval, it's the 800 to 1200. The frequency of that interval is 14. So that's your FQ1. And you've got all the values you need to put into this equation here. You put all the values in, and whatever you get out, that is the answer for Q1. And that's how you find your first quartile. Right. That's how you find quartiles for group data. You follow the same procedure for Q3, the exact same procedure, except your Q3 interval is going to be different. To find that position, remember what I told you? It's 3 times n all over 4. So it'll give you a different number. And then you got to look at where that interval would be. It should be a higher interval. It has to be a higher interval because your third quartile is more than your first quartile. Okay, does that make sense, everyone? Percentiles for group data. Percentiles, Grant, actually a good question. I'll go there. Let me just erase this. The formula is given. I'll show you how to use that formula. Oh, sorry, I rubbed that formula out. Yeah, this. I think this is FP. That's the bottom. Right, so for percentiles, you need to use this formula. it's pretty much the same process. Okay, so let's say the percentile you have to work out is the 60th percentile. So the question is, find the 60th percentile. Tile. All right. Now remember, for this is an example. For the third quartile, it was 3n/4. Now I can also write this as 0.75 times n. With me? It's the same thing, right? So if I wanted the 60th percentile, that's the same thing as saying 0.6 times n, right? And our n is 30. So if you put 30 into that n, 0.6 times 30 is, someone just do that for me, please. 0.6 times 30 gives you 0.6 times 30, 18. 18. Thank you very much. Grant, are you with me? Class, are you with me? How I got to the 18? Okay. If anyone needs me to explain this again, please, please, yeah, tell me. All right, I'll go back to that. All right. So now remember what we're doing. We're only finding position. This is the position of the 60th percentile. This is position, right? So position is 18. So which interval has the 18th number? Here you got the table here, look at it. Which row has the 18th number? Okay, 800 to 1200, Grant says 1600, 2000, right? All right, let's go back, let's look at it, right? Now, on the first row, you have no numbers. We're looking at the frequency column, there's 0. The second row, we got 7 numbers, right? But altogether, it's 7 because 7 plus 0. When I get to the third row, how many numbers do I have in total? I have 21 because 0 plus 7 plus 14, right? It's 21 numbers. So it has to be here. The 18 number has to be here because I only exceed the 18 when I get to the third row. Okay, no worries, it's late in the evening. I get it. But as long as you understand it, okay? As long as you understand how to find that column. So it's the 800 to 1200. So it's this column here. It's the same column we did for the first quarter. It just happened to be the same column. Not guaranteed to be the same, but in our case it is. So now you follow the same process. So we're going to use this formula. The IP, remember everything, you'll get the first number is the lower limit, and then it's going to be plus everything else. The first number is IP, which is the lower limit of that interval, which is 800. So the IP is 800. And then you got this UP minus IP. All it is, it means what's the upper limit minus the lower limit of that percentile interval. And it's the same thing as the class width, because the width of all intervals are the same. If you look at it, everything is the same width. So look at the first interval, it's 0 to 400. The next interval is 400 to 800, which is a length of 400. It's the same thing as C, right? So that's your UP minus IP. That's your UP. Actually, it's LP, lower limit. My bad. It's lower limit, right? UP minus LP. So we've got that. Then you got this P over 100 times N. It's the exact same thing I did here. Your P is 60 divided by 100 times N, which is 0.6 times N, which is 18. So this P all over 100 times N that you see in this formula is 18. All right. Now, what is this f less than for this example? We did this before. How do you find the f less than? Come on, guys, you're almost done. 2 more values and you got it. And you can call it. You can call it evening. What is the f less than? Yes, it's 7. 7. It's the sum of the frequencies before the interval. You don't include the quartile, not quartile. You don't include the percentile interval. You add up the frequencies before it, which is 7 plus 0, right? And then the last value is the denominator, the FP. The FP is the frequency of that percentile interval, which is 14. So you've got all the values. You got to plug it into this equation, and you get your percentile. And as a sense check, always do this as a sense check, right? Whatever the interval was, and whatever answer you get, the answer must lie in that interval. So if you get a value of more than 1,200, you probably made a mistake somewhere. And if you get a value less than 800, you made a mistake. That value must be between 800 and 1,200 because you said that that percentile must be in that interval. So when you work on the final value, it must be a value that's in that interval. Okay, does that make sense? And does that answer your question, Grant? Thank you. Could use some feedback. This is okay. All right, so we covered quite a lot today, this evening. Okay, I hope this helps. Yeah, please, if you're not understanding something, go to this video again, work the example, and if you're stuck, send me, do do the working on a PDF on a page. You can take a photo and send it to me as a PDF, ideally, and then I can look at it and give you feedback if you're stuck. But I'm hoping you don't get stuck. But if you do, that's what I'm there for. You got my email. My email address is damodley. This is it, right? They finalized it. I get all my email on this. Okay, I'm sure you must have figured that out now from New Zealand. Okay. Any questions? Just a last one, no problem. Does cumulative less than frequency? No. Cumulative means you adding up the frequencies before that interval, whereas frequency is the frequency at that interval. Does that make sense, Grant? Okay, good, good. And are there any more questions? You're welcome, Marianne. Okay, if there aren't any questions, thanks for joining. I'll make the recording available probably tomorrow. But have a good evening, everyone, and all the best.